Hello everyone, welcome back to my channel. Today I'm thrilled to begin a new series where we'll explore DevOps, its importance and how it can benefit us in the world of software development. In these tutorial videos, we'll cover everything you need to know from the basics to more advanced topics, helping you become a skill in DevOps. So let's start with the basic question, why we need DevOps? In today's fast-paced digital world, organizations face a lot of pressure to create and release software quickly without sacrificing quality. DevOps helps us to achieve this by bringing together development and operational teams. It promotes teamwork, automation, and continuous improvement. By adopting DevOps practices, we can speed up development, get products to market faster, make them more stable, and keep our customer happy. So whether you're new to DevOps or you're looking to expand your skills, join me on this exciting journey. Together we'll discover the wonders of DevOps and help you land your dream job. Stay tuned for the upcoming videos, but let's dive into the amazing world of DevOps. So in this tutorial, I'm going to explore several topics in several software development, including waterfall model, agile methodology, and an explanation of DevOps and the stages and tools which you're going to use in the DevOps, and what is version control systems, and what is continuous integration and container management, and we talk about containerization, and then at finally we provide something related to monitoring. So uh, to be precise, uh, we're going to start with the roadmap. I'm going to show you. This is the roadmap which I got it online, which is very helpful. You can come to here. So this is the basic version, like what is DevOps, why we need it, and they have provided the complete details what you need to learn before moving into DevOps role. So I'm so you the first thing you need to have a experience on one of the programming language, either Java, Python, Go, anything would be fine. But in this tutorial, I'm not going to cover anything related to this, but I'm just giving a brief explanation of what I'm going to complete, what I'm going to achieve by the end of this series. So I'm going to cover the basic tutorial in this basic part of DevOps in this tutorial. So let's start with the traditional waterfall model. So this is the traditional waterfall model which we are going to follow. So so this is the diagram for traditional water flow, and this is for agile. So we have two type of water flows. So traditional is the oldest one, and this model is one of the earliest approaches to software development. It's a linear sequential life cycle model where each phase must be completed before the next one. So if you see here, think of it as like a waterfall, hence the name, like where water steadily flows downwards without going back up. A real life example could be constructing a building. You start with a blueprint like requirements. If you see the requirement specifications, then construct the building and design and implementation, and finally you paint and furnish it, and testing and it would be testing and deployment. However, the waterfall models has its limitations. It's not suitable for projects where requirements are likely to change, as it doesn't allow for more flexibility. Once a phase is completed, it's difficult to go back and make changes. It's like constructing a building and realizing halfway through that you need an extra floor. It's impossible, right? But it's going to be costly and time consuming. And if you see here, we are in this waterfall model, so there are multiple steps which required, as I explained: requirement specifications, system design implementation, verification and test, system deployment, and software maintenance. And there is agile process, agile methodology comes in. So since it's very impossible to make any changes, so we have added agile methodology. So in agile is an iterative approach to software development. So in agile, let's talk about each step. Project planning. We start by deciding what we want to create and why. This is our project's goal. And product backlog creation. We make a big list of what the project needs. This could be futures, fixes, or anything else. The list is called the product backlog. And the next one would be sprint planning. So we pick a few things from the list that we think we can do in a short time, usually 2 to 4 weeks. This short time is called a sprint. And the next one would be sprint execution. We start working on the things we picked. We design them, write code, and test to make sure they work. And then the testing part. So we'll do while we're working. We'll also test. We want to catch any mistakes or problems as soon as possible in this part. And then we'll review. At the end of the sprint, we show what we have done to the people who asked for it. They give us feedback and tell us if we need to change anything. And we have a retrospective. We have a team meeting to talk about what went well and what didn't. We try to learn from our mistakes so we can do better next time. And it goes on. It's like a cycle process. And next sprint planning, we go back to our big list and pick the next things to work on. Then we start a new sprint and do it all over again. So the idea behind Agile is to work in small steps and always be ready to change our plans if we need to. It's a flexible way to work on projects that can change a lot. So that's what about Agile and Waterflow. Um, so let's go ahead for the next step, which would be uh, let's talk about DevOps. Yeah, I have created a sheet for this. So these are the DevOps components. Basically, let's talk about DevOps first. So DevOps is a culture that promotes collaboration between development and operation teams, and it's supported by a range of tools and practices that can help to increase the speed and reliability of software delivery. It's like a relay race. We like where each team member plays a crucial role and passes the baton to the next, working together to reach the finish line. DevOps involves several stages and tools. We start with version control. So this is usually the let's before talking about the version control, I'm going to show you this is how the life cycle works. We use version control as a Git. Most of the people will be using Git, or GitLab is also fine. We try to push the code and we done in the development and fetch the changes and run. And Jenkins will be the tool where we're going to use to fetch the changes and run unit tests using Maven and or using Maven or Gradle. And we build the artifacts and then store the artifacts in Sonar Cube or Nexus, and we provision the environment in like any cloud or any on-prem services and deploy or build. We can use Ansible for configuration management and usually Chef for Kubernetes. And also we run load and functional tests using JMeter or Apache. The main word would be Selenium or like JMeter. And then we once the code is packaged and done everything, we try to deploy to dev first and then QA and then staging and then production. So this is the normal DevOps life cycle. And we usually what happens is, so we developer team will be building the code. They test it and plan, and then we're going to so so we have two types of parts in DevOps. One is development and then is the operations teams. So why DevOps has came to the picture is like whenever there is a whenever developers develop something on their code, and they say it works on their local, but whoever takes that code to deploy and release do the release will be operation team. So operation team will have a lot of issues while trying to run the same code which has developed by dev in the production environments, or you can say any staging environment. So that's where there will be a lot of discrepancies between the local environment of development team and the production like environment. So to reduce the discrepancies between here, DevOps comes in. So we basically, DevOps involves stages and tools like I explained you. We start with version control, and where we manage and track our changes. It's like a time machine allowing you to go back to a point in your code's history. And next we have continuous integration. Um, so so this is the similar example we use, but so developer has provided a source code and commits the code. And for the continuous integration, we integrate our changes with the main code base frequently, And Jenkins is our popular tool for this, automating the process of code integration. It's like a quality check in production line, ensuring each part meets the required standards. And then comes the configuration management, where we manage the configuration of our systems. Uh, I personally use Terraform, which is very often used for this, and ensuring our systems, which will ensure our systems are configured correctly and consistently. And we have there is a rule called CRUD, CURUD, create, remove, update, and delete. So that's what it is. I think we can do anything in like in minutes. If you are new to this tutorial, I suggest you to go back to my first video. I have explained about Terraform and installation and how we can create multiple instances in AWS. So that covers the Terraform tool. But let's not go there. And this is the build tool. So once we trigger the jobs and integration has been completed, we will initiate a build, and we use the build tool, either Maven or Gradle. So these are both are different for the Maven is used for Java application and Gradle is used for DLS jobs. Let me show you example. Yeah, this is Groovy. Actually, DSL is nothing but domain specific language. Usually we use XML, extensible marker language, for declaring the project configuration. um, like in here we do everything like building, testing, and deploying software, and this is the tool which we're going to use. And first we're going to integrate that to Jenkins to perform this. Also there is one more called Maven. I have a document. Yeah, this is the Maven build structure. So once we have the build, we'll be creating a build artifact using Maven or Gradle. In this case, I'm explaining about Maven, which will be a Java application. So we will validate and compile and test and package the build artifact, and then verify, and then install, and then deploy. We'll So that's what it does. Returns the build artifact, runs automated tests, and runs test results. So once this is done, we'll create a setup called test suite, which will be testing the application. Like we'll have a basic every application will have a basic kind of test suite, which will be provided by application or engineering team, or maybe the project team. They will they will have some requirements where they want us to test after the basic build has completed. So to test the developer's code, we'll have a dependencies check on test suite. Once this is completed, is successfully completed, we are going to deploy it to dev environment. So before going, we will going to deploy into dev environment, and if the test pass, we'll deploy application to dev environment. And if that if the test has been completed successfully, then we are going to deploy it to staging, and we're going to do the complete testing and staging by testing team. And then once everything has been approvals has been we got the approvals. Once we got everything in place, we then push the changes to production environment. So let me explain you something related to continuous delivery. One second. Yep. So let's go back. So continuous integration, I explained about Jenkins, and configuration management, Terraform. So continuous integration, we integrate the changes, which we pull the changes and test it and deploy to our deploy the software, and we test them. And management is something we create an infrastructure basically to deploy the code, which we get it from developer. And then containerization, I have a separate playlist for the Docker. If you want to go look at it, you can go to my playlist and look for the Docker. You will be able to have more understanding. But Docker is a platform where it will use a OS level virtualization. So if you already know about virtual servers, so we it's like creating a containers inside the virtual environment. It's like using we'll have a virtual machine. The difference between virtual machine and containers are, virtual machines are a single host which consists of all the application, all the components in single server, like application, database, and other part. But in when it comes to containerization, we only you maintain the application, the components within a separate folder or a separate allocation, where we basically use the shared resource of OS. The OS level virtualization will be same, but we'll be creating packages like a packages in containers. So these containers are isolated for each other, and they can use their own software libraries and configuration files. And the last finally would be the monitoring and the Splunk. I'm giving example of Splunk, but you can use anything. In AWS we have Datadog and or something like that. But right now I'm concentrated on Splunk. So some Splunk is a software to search and analyze. So this is the diagram for that. It's basically let me this like we have this is for continuous monitoring, where we monitor our systems and applications to ensure they're functioning correctly. Splunk is a tool that often used for this. It's like a security camera constantly monitoring for any issues. Um, like the code will generate a sequence diagram. Like I have provided a sequence diagram where a user generates a data which is captured by Splunk forwarder. We need to install Splunk forwarder in your server, in the application server, to get this data basically. And the Splunk forwarder sends this data to Splunk indexer. The indexer index this data. Indexes is something like querying the logs. We have something a central position where or we kind of use a name for index. From using the index name, we are try to retrieve the information on the servers. And these indexes the data and make it searchable basically. And the user submits a search query whenever you via Splunk search head. The Splunk search head requests the relevant data from the Splunk indexer. The indexer returns the search results to the Splunk search head basically. This Splunk search head displays the search returns to the user, and something like that. So it's similar to trying it will this process will automatically provide we search for something through a Splunk URL. It's like we have a separate through these indexes we'll be creating a URLs where it will be environment specific, and we'll at the final goal would be we'll be providing we'll be getting a Splunk like the results of the logs. It's more often used for logging, monitoring, and we can also use the index to retrieve the error like strings. We can also mention error codes or any particular string related to our application. I already have explained about Terraform in the previous videos. You can in the initial video actually, but I'll explain you in real quick. So this is the user. Whenever we create the Terraform files will be configured, like we'll be placing the Terraform files in .tf files, where we'll mention providers and what we want to create. Like in AWS we have VPC and we have security groups, like network gateways and subnets, and all the configuration needed, and a VM instance and what kind of instance we're going to. And this configuration files will be triggering we'll be using a access key and security keys from AWS through these configuration files, and trigger a Terraform init, where it will try to pick up the configurations AWS plugins specifications from AWS and use them to create a Terraform core, which is the main infrastructure code using the using the AWS and Terraform config files. Will be triggering a main file which has a backup file as well. Is nothing but a backup file. It will always stores whenever there is any changes or any deployments has been done. This state will be updated basically. So that's how we deploy something in cloud servers. And the final part would be, I think I forgot to explain about Git, the source code management. So I have explained about these things, but I didn't explain about Git. Git is a source code version control or source code management that tracks changes to source code during source software development. I'm going to show you how we can do it. So this is the example. We have two type of Git version control systems we follow. This was a previous, we used to use this as centralized version control system, which will be the early times which we used to use. And the distribution version control system is the one which we are going to use in the present day. But I'm going to explain on both the topics. Centralized version control system is something, we have a centralized server, like centralized repository for all your working copies of your, like you can think this working copies as a developer are working on a working copy. So they try to take a copy of this repository and place it in their local, like three developers, like three workstations. And they can do is they can update and commit, like they can pull the changes from here. Once they take the pod, they do commit, and the changes will be present in repository. So this is very basic part. I think it has a lot of complex issues because everyone will be using the same version control system, like the same centralized repository. And if something goes wrong on this repository, all the code will be gone, and that's a risk. That's a risk we have with using centralized version control system. Whereas distribution version control system, we have distribution version control system. Is type of version control system that allows multiple developers to work on a project simultaneously, even when they are not connected to centralized server. Unlike centralized version control system, where developers need to be constantly connected to central repository, um, this version control system provides a local copy of entire repository to each developer. Uh, Here's how distributed version control system works. Local repository, where each developer working on this project has their own local repository. This repository contains a complete copy of project, entire history, include all files and version history. And when we commit change, developer can make changes to files in their local repository and commit to these changes. Commits creates a new version of the files which is recorded in the local repository. And then which allows the developers to create branches in their local, which are independent lines of development. Developers can work on different features or bugs in separate branches without interfering with each other's work. And also we have this worker version control system also provides a mechanism to synchronize changes between local and repositories. Developer can push their local commits to remote repository, allowing other to access and incorporate their changes. Likewise, developers can pull change from local remote repository to update their local with the latest code actually. So the key benefits of this was we can work offline, we can the faster performance, flexibility and independence, and collaboration as well. It's good for collaboration. And when we come to here, I think so this basically covers the master branch. Like we will be creating whatever explained here. This is the git flow actually. This completes, we have a working directory where we added some changes to local. With this will be staging area is nothing but your local, and then we do commit to a local repo. So whatever added changes has been committed to your local repo. I'm going to show you like in the terminal how I'm going to create a new repository and create a new repository and make some changes and pull the changes and push the changes to the remote repository. And this is how once we do the commit the changes, we can push that to remote branch, which would be the main branch, like master branch. And we can do git pull as well. So this is the initial work which we do. Like we pull the changes from remote. That's the best practice we do. We always pull the changes before making any changes. And then we can also git checkout, and then the following the process will be continuously. It will be a cycle of process again. Once we git checkout, we create a new branch, and then that would be a working directory, and then stage the stage within the working directory. We will have a stage area where we add the files and then commit and do it, and vice versa. That's how it works. Of this, so right now I will create a new repository. So let's say demo. Okay, and then add a file and then create a repository. Okay, this is I created a new demo file. So I have got this document. We're going to do this. So we created a new repository in GitHub, and then let's go to a folder where we want to. Okay, a directory. Let's say demo. Okay, we are in the already. So let's follow this. So git in is nothing. It will initialize the git repository. Basically, we'll just copy that, and this will, yeah. So it has initiated empty git repository in here in the demo folder. So what next will be, we'll since we will add something to this file, like okay, sample.txt, something like that. I for insert, and then do demo for DevOps introduction, and escape colon WQ. Okay, escape colon WQ, and quotation will be command for saving the file if you're new to this. And then if you do git status here, you can see we have added a file, and it's untracked files. So that's what I want to show you. If you go back, so this is a working directory. I have created some changes here, and I checked for the status. So right now I can see a file has been not committed or not added. So nothing, if you see nothing added to commit, but untracked files present. So we need to add a git add command to track. So let's do git add, and preference, it will add everything has been present in the local directory. And let's do git status again, and now you can see changes to be committed. So we are ready we can commit these changes now. So let's go back, and we have a commit command. So let's do, so this command will usually do git commit -m is nothing but the command name. We just provide the is the operator to provide the commit name. So let's run this. So we put, the file has been committed. So let's go back and look around our sheet. Okay, if you see here, the main branch, we have a main branch here, but in a local it's been created master. So to fix it, so we need to change this master to main. I have a command for it. So let's copy this command and then do this, and now it got changed to main. So that's how it works. So let's go back to our thing. So now you can add the repository. We need to add our remote repository. Let's go ahead and do it. We need to provide the URL. Okay, I think I messed it up. One second. Okay, yeah, I got the repo. So just do it. Okay. Now let's do git pull origin. Okay, we'll just pull the changes from the GitHub repo now. Okay, let's see if we got the changes. Okay, I think for fixing this, we need to run this command. What is the command? One second. Yeah, we need to pull using origin main, allow unrelated histories. So we need to make sure we have it saved. Okay, now one got failed change. Let's do git. So you should be able to see the file has been copied now. See, so this readme we didn't create it, we pulled it from there. So now what we can do git push the merge. So what it does is the created sample file text will be pushed to the GitHub repo. If you refresh here you go. We got the sample.txt which we created in our local, and it got copied to our Git repo. So yeah, I think I covered most of the part. Okay, there is one more thing I want to add on. So I forgot to explain about the basic part. Okay, let's go back. So we covered everything in this tutorial with explaining about traditional waterfall model, limitations of water model, agile model, and as well DevOps and DevOps stages and tools which we're going to use in this integration with continuous integration, delivery, deployment supported by multiple various tools, and version control details. And I have provided example how we can push and pull the changes from local to GitHub repo, and also continuous integration. We have Jenkins, and also configuration management. I explained about Terraform and Docker, and as well monitoring Splunk. I explained about Splunk. Let me give you a simple example actually. So this is a simple example for application to how the application works. So Once the developer pushes the code, the Docker file, in this case, using the GitHub repository, the Docker will be triggered using we can add a condition to trigger the build once we commit a change to the source Git repository. I can do it. I can show you in the next video when we do actually the deployment, and then this triggers the Docker build, and it will kind of pulls the Docker file and code and creates the and builds a Docker image. And this Docker image, using the Docker daemon, it will pushes the Docker image to Docker Hub, which is the which is a place where all the images will be present. Basically, all these images will be present. So we are going to push it image, and from there we're gonna pull the Docker image. Once it's copied, we're gonna pull the Docker image which we sent using Docker registry and deploy to production environment. So this is the basic example of how the deployment works. I can add more details on the next video. So that's what about the details. So yeah, I'm in the next video I'm going to talk about Linux. So this tutorial pretty much covers about DevOps and introduction DevOps. So this is just the DevOps. So I have explained everything in theoretically. So from the next video we can if you go to our roadmap. So this is the roadmap. So we covered the basic DevOps part. What is DevOps and what are details we have in our you need to know before using DevOps basically, and then we need to have programming language. But for now, I think we can skip this. But if you want to learn it, that would be very great. But right now, I want you to concentrate about Linux, so which I'm going to cover in the next video, and then the vice versa. I'm going to talk about all the things. Also, there is Docker, Git, AWS, Terraform, Ansible. So I'm going to cover everything one by one. In each video, I'm going to discuss about the details, and also I'll provide a basic example of how we can do it. And finally, I think we are almost done. So this is the high level roadmap of what we can do. So, and the next part is, in conclusion, the DevOps is like we covered the brief view of all DevOps. It's a culture that promotes collaboration between development and operation teams, and it's supported by a range of tools and practices that helps to increase the speed and reliability of software delivery. In conclusion, DevOps is all about improving collaboration, efficiency, and speed in software development and delivery. It's a powerful approach that's becoming increasingly important in today's fast-paced software-driven world. Yeah, that's all for today. Thanks for joining us in the tutorial. We hope you find we hope you find it informative and helpful. If you have any questions or comments, please leave them below in the video in the comments, and we'll do our best to answer them. Please don't forget to like this video and subscribe to our channel for more tutorials on DevOps and other tutorials. Thanks for watching. I really appreciate the response, and if you have any questions or anything regarding the DevOps, you can always try to comment on the details. I'm going to respond it to you. And